Okay, so when we have a quadrilateral, so a shape with four sides, when it's inscribed, so that means that all these points, all the vertices of the quadrilateral lie on the circle. All right, we have this theorem right here that opposite angles are supplementary. All right, so these angles are the angles that relate. So all this means is that 83 plus y equals 180. So y equals 97. That's it. That's all you got to do for that one. All right, a specific fact that you got to know. All right. Another specific fact is that this is an intercepted arc. This is a inscribed angle. All right. All you got to know is that to get from arc to angle, the arc is double the measure. So all you got to do is divide by 2. That's it. To get from intercepted arc to inscribed angle, you divide by 2. So angle ABC right here is just 60 degrees. You just take 120 and divide by 2. Sweet. All right. These next ones are hard unless you draw a picture. If you draw a picture, it will become tremendously easier. All right, so point A, B, and C lie on a circle with center Q. So let's just draw that. Some random circle, center Q, and A, B, and C all lie on it. All right. The sector of ABQ is twice the area of sector BQC. So that means that if this has some area X, and remember, a sector is like a pizza slice. So that pizza slice is X. That means that since this pizza slice is double it, it will be 2X. All right. All right. So next, if the length of arc AB is 28, what's this arc down here between B and C? Well, notice how we go from X to 2X. So question mark to 28. That means it's just 14 centimeters. That's it. All right. So very hard problem. Unless you draw it out, then it kind of becomes crystal clear. Same with this one. A circled center with L contains points J and K. All right. So we're going to just go and draw some circle. Center L, J, and K. All right, it's dilated by a factor of 2. Dilated means it can get bigger or smaller, but since it's getting bigger, or since we're dilating by a factor of 2, that means it's getting twice as big. All right, and it results in a new circle, circle P, where points M and N are on the circle, such that these central angles, JLK and MPN, are the same. All right, which statement correctly identifies the relationship between the arc length of JK and the arc length of MN? And if we read through all these half, half, quarter, quarter, well, we know that the scale factors, all right, the scale factor is 2. So we can exit out anything with a quarter. All right, that just doesn't make sense. It's going to have to be with a half. Something's half the length of the other one. And in fact, if you read it, the arc length of JK is half the arc length of MN. That's that one. All right, we have JK, and then we have to multiply it by 2 to get MN. So it's that one right there. All right, so by drawing it out and identifying that the scale factor is 2, we could eliminate the quarter ones. We made it a 50-50 problem, and then our picture helped us visualize that it was in fact A. All right, and then last one for this page, point -3, 2 lies on a circle whose equations x plus 3 squared plus y plus 1 squared equals r squared. Determine the radius. So this is a classic plug and chug. All right, you're gonna plug in -3 for x, -2, or excuse me, 2 for y, and you're gonna calculate. All right, so you're gonna do -3 plus 3 squared plus 2 plus 1 squared equals r squared. All right, we're just solving for r. We got a point, we got the equation. What's the radius? -3 plus 3 is 0, 2 plus 1 is 3, 0 squared is 0, 3 squared is 9, 0 plus 9 is 9. It's 9 equals r squared. That means that regular r, the radius, is in fact 3.